the season. Right. Let's get right into math practice. Bum, 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 guys see that okay?
Yep. Mm-hmm.
Yeah. All right. I want to get into first the status where we're at, which is really good shape. Probably the best ever, honestly. This is what I have. I think I think I'm up to speed here. Jody. Oh, I just got yours, Nick. I don't know if Nick's on. Bingo. That's about as many hundreds as I've had at the last class. So well done, people. Staying with it. I'm going to turn off my video so I don't distract you people with my mug. And homework from last week. Basically, I was looking you to do a control chart. Um, like that one, that one's when I was big variation really there, from 200 pounds almost to somewhere around 170-ish, which was more recent, as you could see. So the homework was to do the same, except with just 2024 and 2025 data. Here they are side by side, much different. Um, the upper control limit's only 182 or so. I think I could just look 182. Yep. And the lower control limit is 168. And then the mean went about 175 before the mean was 185, I think. So, and then the idea now too is I can take those control limits and start to squeeze them together. Just in case you're interested, what you'll kind of notice is my weight peaks during football season because I eat out a lot, traveling, it's beers with the guys. And then I get good after the first of the year, but then this year I got the wedding and bachelor weekend, the wedding, all that trip to Florida, the whole 9 yards. But it's kind of cool where you can, make data that just sits there on the page and kind of make it talk. And I bet you, so one idea too, guys, is for the final, which is going to be coming up, which I've mentioned here. Give you the game plan. Sorry about this. So I did, all the captains of the group leaders have thankfully accepted the role, and they are Jason Rose from Ulrich Steel, Marcus and Meg from PTA, and Marissa from Ulrich Steel. And I've color coordinated those group leaders. So anybody in yellow is with Jason. So it's Craig, Bev, Tyler, and anybody in blue is with Marissa. So it's Ed Metaboni, Abhishek, Laura. I'll send you guys, in the email, the breakdown. And it's basically I just pick, put four teams together. So, there comes Nick. Put four teams together. No homework today. Going into next week. Next week we're going to do the exam review, and then I'll kind of fill you in a little bit more on the final presentation. I think the final exam is on a app called Class Marker. So you get an email with a link. Go in and do the 40 questions. I would suggest that maybe it's a good time, for the group leaders to pull their teams together. Maybe do the quiz together or test or whatever exam. I guess you're supposed to call it. Because and then hopefully you'll have a couple of opportunities, a couple meetings to pull together the final presentation. So the final presentation, I did send you a few examples. I'm going to send you a couple more. People have used my health data. In that case, I would add. I'll probably send this to you, but I'm going to add blood pressure and pulse rate in case you want to use that. In terms of, is there any correlation between weight and blood pressure? Is there any correlation between blood pressure, weight during football season, whatever? But I can send you a couple examples of the final presentation where people have used that data because all you really need is a data set. I think it's much more interesting if you don't, if you can find, something from PTA, Ulbrich, Atlas, LMC, to do, Hubbard Hall, some data set that you could make data talk in 15, 20 minutes long. I mean, it's 4 people per team, and you'll have 2 weeks to do it. Because the plan is the final presentations will be August 11th. So next week, review exam, I'll send the exam out. Now you got from next week, Monday, for 2 weeks to put together that presentation and finish the exam. And the exam is open for 1 week. So you'll get it next week, Monday. It'll be due the following week. All right. Any questions there in terms of we're down the stretch we go? There should be zero anxiety because no, like I said, no one's ever gotten lower than 80, maybe. Not always pretty good. So I'm definitely not worried about you guys. So today we're going to finish up control charts, and we're also going to get into if I can get to it. I know there's easier ways to do this, guys. Just all right. There's another tool that you can use called the cumulative sum, and we're going to cover that. And we're going to cover a couple more control charts, like 4 more, that have to do with data that you count. Okay. Basically, what we're looking at here, I mean, our control chart was stuff we measure. So the ones we're talking about are things we can count. Defects and defectives, that type of thing. But before we get into that, here's one last control chart for things that you measure. So I thought I'd give you guys a break from my health data, my weight, pulse, and all that. And I thought I'd share with you some sales data from my wife's frozen yogurt shop. So she opened it up in February of 2014, and she sold it July of 2021. And each week, just like my weight, I would record weekly froyo sales. All right. So if I just take these two here, week froyo sales, and I want to insert a recommended chart, the one you got here is the second one down. I didn't use a dot scatter chart. We use this one. And it's kind of interesting. Maybe you guys could help me in terms of what do you see? There's the weeks down here. Frozen yogurt shop in the middle of Connecticut in Windsor. What do you see?
Sales are declined in the winter.
Ah, bingo. Is that Abhishek?
Yes, sir.
You can start, all the lowest points are all pretty much December, February, March. Exactly. People aren't really all excited about froyo then. What else? Anything else you see?
It has a common pattern, goes down and goes back in summer.
Goes back up during the warmer months. Something I like to point out is if you look at 2020, 2021 down here, it went down and kind of stayed down. Any idea?
Pandemic.
Bingo.
Yeah, say COVID.
Yeah, exactly. COVID. Then, because we were like hemorrhaging money, obviously, yeah, you got help, from the government, but my wife decided that she wanted to do frozen yogurt cakes and use them as fundraisers for all the local schools, in all the towns around Windsor. And we saw a pretty big, all of a sudden, and this is where she sold it up here. So because before the pandemic, she was like, you know what? It's like having a heroin addiction. I think I want to opt out of this. So we had already started the process of unloading it. Interesting though. And then the downward trend, I think back in 2014, every strip mall had a yogurt shop. Yogurt was flying. And then it kind of lost popularity as people got saturated. So you could see the trend line in that direction. So another way to plot this, and what we're going to cover today, is cumulative sum, where largely I take the same data week by week, and you just add March 3rd, February 25th, and then to those two, you add March 10th, then you add 317 and plot that, and you end up with that. So that's the cumulative sum. And there's my midline right there. And so COVID is this this gap between trend line and the blue line. And you can see the summers. And I could, you could expand this up, maybe not look at it so much weeks at a time, something like that. But it's just another way of looking at the same data. Another control chart. Can't say I've used that one much, but it's not on the exam. But I thought I'd show you because we're going to talk about it in the PowerPoint. All right, let's get into the fun stuff, the PowerPoint. Which is right here. Right. You guys see it? Okay. So this is kind of like a roadmap for for the which of the control charts you want to use, depending on what kind of data we have. Very similar to hypothesis testing. We want to make sure we pick, what we're after. Let's pick the right one. So again, is it a continuous or attribute data? Continuous, things that we measure. Attribute data, things that we count, otherwise known as discrete. Either one, discrete or attribute, same thing. If it's something that we measure, we're going to do, depending on the subgroup sample size, we're going to do probably the most popular, the one you guys are probably going to use the most is that IMR without the MR. Maybe you might use the MR if you're ambitious. You can. But most of the time we use an eye chart. Or if we have 2 to 9 samples, we're going to look at the X bar R. We covered this last week, or the X bar S. We just covered the cumulative sum, the special purpose type of a control chart. And then we're going to cover today also in the PowerPoint the exponentially weighted moving average, where we want to compare more recent data with data from 5 years ago or 10 years ago. So we give the old data less weight than the new data. So those are all the possible control charts for data that we measure. On the other side, data that we count, it's pretty much either, is it a defect? Are we going to count defects or defectives? Just a reminder, a defective is a part that your customer will not accept and will send back to you. And a defective part may have many defects. So if we're talking about defects, then what size sample are we going to do? If it's constant, we're going to do a C chart. If it's variable, we're going to do a U chart. And then if we're counting defectives, then again, both these 4 depend on what my sample size is. If it's constant, I'm going to use an NP chart. And if it's variable, I'll use a P chart. What does all that mean? Let's get into it. So the NP chart, it's a control chart that monitors the count of defectives. So I ship out 1,000 things. How many of those parts were defective each day, each shift, some time period, right? So the NP chart plots the number of defectives in one subgroup as a data point. The sample size is constant if you want to use the NP chart. So it's always going to be, SQL, 10 samples, sort of every 100th sample, or every 50th, or every 10th. And the underlying distribution is binomial, which means the value is either going to be 1 or 2, either good or no good. That's all binomial means. Same thing with, votes, counting votes, or yes, no, heads, tails. Those are all, if you plotted those are all binomial distributions. Here's so again, when we went through the homework, the center line was the mean. In this case, here's the formula for the center line. There's our data point, and then our control limits plus or minus this equation. You don't have to worry about that. I just want to show you how consistent it is, where we have an upper control limit, we have a midline, and obviously the objective is to stay process variability, keep it to a minimum and keep things somewhere around the center line. So the ones on top here, they're in red. They're outside of the upper control limit, which was determined by that formula. And we would conclude that the chart is out of control. And again, it just causes us to think, is this Saturdays, right? Or is this new people that we hired, or it gives us clues in terms of how do we, because these are definitely special causes of variation, versus common causes. So, we have the ability to look at this and say, all right, what happened? Otherwise, the chart's useless. It just takes up space on our computer. P-chart, same thing, except now we're looking at percentage of defectives. All right. Before I was looking at the actual number of them. So now the sample size doesn't need to be constant. All right. Still binomial distribution, which, one of two options, yes or no, good or no good. There's the formula for the center line. Don't worry about it unless you're on a deserted island, you got nothing to do and you want to try it. There's the formula for control limits. And again, it doesn't matter what sample size I have now because I'm going to be charting percentage of defectives. Okay. Well, following this logic, when we get into the defects, same exact thing. The C chart is the count of defects per unit of a subgroup. Sample size is always the same. We're not talking about defective parts. You might have 4 defects on one defective part, So the underlying distribution is a discrete probability distribution. How many times an event is likely to occur over a specific period. That's the distribution we're using for a C chart. There's the formula for center line and the control limits. And again, sample size has to stay the same. There's the formula for control limit. This number came out of that formula on the previous slide. And there's nothing on the exam that's going to ask you to calculate these or anything like that. These are just so you know, hey, if at some point I want to do a control chart for defects, defectives, there's something, where I'm collecting discrete data, you've seen it. So the same thing, U chart is the same thing except percentages, average number of defects per unit. So now we're going to average the number of defects per unit. So I ship out 1,000 units. I get what's the average number of defects out of all the defective units that I just shipped? God, imagine trying to stay in business with that kind of mindset. Anyway, sample size is not constant. There's the formula for the center line, there's a data point, and then the control limits. The data point is obviously just the average, mean. And now again, we don't have to have a consistent sample size. All right. Cumulative sum, which we just went through. It's a control chart monitoring the cumulative sum of the sample mean deviations from the process target, which the yogurt sales. It detects the shift of the process mean from the process target over time. The underlying distribution is a normal distribution. And there's 2 types of cumulative sum charts, 1 and 2-sided. 2-sided, we use a VMask, which I'm going to show you in a second, to identify out of control data points. As you can see, like there was very little, unless you have good eyes sometimes, which data points are off that center line, which ones were on it. A VMask helps us quantify how far that, those points are off the center line. This is what a VMask looks like. And it's kind of just drawn right over top of that, that yogurt graph that I showed you, that straight line that I showed you. And there's the upper boundary of the VMask. There's a formula that determines, where you plot this. Here's the formula, the slope, and the width and the width at the origin point. Excuse me. EWMA. Let's say a manufacturer produces a widget of a certain diameter. If diameters are off, there are consequences. So using this chart helps us understand the manufacturing wear and tear over time and its impact to the creation of those widgets. So it's a control chart that monitors an exponentially weighted average of previous and present subgroups, averages. Okay. More recent data get more weight than historical data. It detects the shift of the process mean over time. And you can actually do an EWMA with my weight, for example. The underlying distribution is normal. Here is the formula for center line. It's going to be the average of my data. And there's the formula for data points and control limits. And this is what it looks like. So the control limits are calculated. If you think about it, so were the ones when we did my weight also. And one data point falls beyond, and we conclude the process is out of control. But it gives weight. All you need to really know about this is that the WMA, it just gives more weight to more recent data. All right, let's talk about some control plans. Um, Control plan objective is to sustain results. This is the most overlooked and underappreciated part of the DMAIC. Um, second law of thermodynamics. I think it's the second law, right, guys? Where if I leave a process unattended, it's going to spiral towards unorder, towards chaos eventually. Right? So I have to kind of pay attention, and that's what the control plan's about. About how do we roll out the changes to the whole organization, communicate it, make sure that we're ensuring compliance, auditing, corrective actions, ISO, all that stuff. We want to transfer our learning across the enterprise, coordinate ongoing team and individual involvement, standardize how we're going to collect data, how often, who's going to do it, how we're going to test it, the whole 9 yards. We want to measure process performance, stability, and capability, and plan actions that mitigate out of control conditions. What happens if it starts to go wrong? And as luckily for you guys, you just got through the control chart, so you know when it's going to go wrong. So the control plan is it's a summary documenting the detailed key process steps, critical to quality metrics, measurements, corrective actions. It might have SOPs, it tells people who does what, when, and how, and a communication plan, how we're going to deliver that to everyone. Might be a training plan involved, where we have to teach people a whole new way to successfully perform the new processes and procedures. We might have an audit checklist, to make sure that they can go check at any time. And a response plan when it fails. So it's a management planning tool, and it's used to identify critical steps that have significant impact, establish control mechanisms, identify, describe, monitor the process performance, and to make sure that we meet the customer specifications consistently. It's generally the most overlooked element of most projects. We kind of cheer it on. We're really happy and pumped up, and then we walk away. There's a formal control plan. Do an Excel if you wanted to. I'm going to send you guys all the slides. There's the key processes and processes steps that are identified. What's the information, critical quality characteristics, and how we're going to measure it. CTQ targets, specs, upper and lower specification limits, how we're going to measure it, what size sample, how often, who's going to do it, where this will be found, where we're going to record it, identify mitigating action or corrective actions if it falls out of spec, who's responsible for action, and what's the corrective action going to be. SOPs, documents that, process steps, activities. You guys are all familiar with SOPs. Required to complete an operation. I kind of think of these as training documents. Sometimes they're not used that way, but I think using them is probably best practices to use them training new people. I know PTA, Ulbrich Steel, we've gone through training within industry, where basically it's not 2 to 4 pages, but everything I need to teach somebody a task is done on 1 page. And that was the TWI was used during World War II when every adult male over the age of 17 was sent off to war, World War II, and new people had to come, mostly women. Rosie the Riveter had to go into the factories and learn how to make bullets and bombs, and I think that was how we ended up winning the war, was our ability to replenish and our ability to train using this TWI method. Unfortunately, a lot of times I see the SOPs they're kind of tucked somewhere in a file somewhere, and they're not generally used either. They don't see the light of day very often. Communication plans. How are we going to do that? So I love closings. The closings are part of the communication plan if you think about it. Timely and accurate messaging. Who? What are the key points? Who? What? When? All that. And the training plan used to manage the delivery of training. A lot of times we've changed the processes so much that we got to invest in training for our people. And who, what, who's going to complete it, when will it be done, what's the timeline to train everyone, and what will trigger ongoing training, new employee, refresher, periodic, retraining, um, logistics, things like that. And then your auditing, um, independent examination, determine whether quality activity. Basically, it's saying, this is what we say we do, and they just audit to say, make sure that we do exactly what we say. They're used to ensure actions and processes and procedures are performed as expected, or how we think, what we expect, how we want it to work. Are we doing what we say? An audit's purpose well defined and executed by independent and biased personnel. I know I have Atlas on here and Hubbard Hall and everybody here, I guess. Yeah, I mean, I think even Tyler, with all the stuff he has in NADCAP and all that stuff, someone comes in and says, "Yep, you're doing what we want. What you said you were going to do." And there's a checklist usually. It serves as guides for identifying items to be examined, using conjunction understanding, sure well-defined audit scope, etc. And there's the checklist, review of training records, a review of maintenance records, questions or observations that focus on expected behaviors. Um, Response plan, when stuff goes off the rails, what are the triggers? And again, your control chart is one of those, right? When I see all of a sudden I see an outlier, it's outside my upper control limit, or in some cases under my lower control limit, that's a trigger. What's the action that's recommended if all of a sudden, I'm doing a control chart and I get two that are outside, or Westinghouse rules also, those 8 rules. What do we do? We just ignore it. Who does it? When do we take action? And then recording what actions have been taken. How do we prevent it from happening again? I like A3 a lot here. And constraints, thinking about those in the control phase, where people, lack of project sign off, lack of involvement in the control plan design, um, whole bunch of possible roadblocks, constraints, lack of buy-in from everyone, just went back to doing it the old way. So anyway, there's everything you ever want to know and more of what a control plan is. Lean controls. We have lean in every single one of our parts of the Mac. 5S is probably the starting point with control. People think it's about cleaning and organizing, and that's the way this whole course says it right here on the course, but it's really about visual control and standard work. That tells me I walk into an area that everything is on time and things are, progressing as they should. Nothing's leaking out of any of the machines or the equipment. There's not excess noise, from one of my pieces of equipment. It's about a visual factory. 5S is part of a visual factory, as you guys know. And again, it's being able to see. Lean is a lot about visuals. And then the standard work helps provide consistency. We went through the 5S's during the improve phase. There they are: sort, set, shine, standardize, sustain. We could add step 6, not really step 6, but safety is woven into this process. But again, it's getting everybody to do a little bit every day and not just when things start to go off the rails. Other control tools, Kaizen, where you can, as an organization, a philosophy of continuous improvement. Because again, if I have an outlier, if I have something go wrong, what good is it if I don't have a process in place in my business where people can say, hey, I got to get this fixed, and be able to pull a team together and very quickly go after these things. Hopefully, you don't have to get to a Kaizen event in order to do that. You can snuff it out early. Um, Kanban is another example of lean control. Things like K cards, Kamishibai cards, red and green when the task is completed. Go. I think we did one out in South Carolina. I think Jason's on here, right? Jason Rose. Um, largely it's, hey, you know what? Work's been done. That's about standard work. Poke-OK, we covered that last, in the improved phase about mistake proofing and defect prevention. In our new process, if the same mistakes are happening or they're happening more often than we want, if the student hasn't learned, the teacher hasn't taught, and we need to find a way to make the work much more mistake proof. And two types again of mistake proofing, prevention and detection. Preventing is preventing it from happening. Detection is when it happens, I get a light that goes off or a bell that rings or something. Contact method, constant number method. This is a review from last time, or sequence method. Okay, mistake proofing. Preventive maintenance, and that's reducing and eliminating equipment malfunctions. Um, it's proactive. It's not allowing our equipment and our machines, even, I mean, for you folks that work in the offices, same exact thing. What would it be like if we were down, right, in there? What would that look like? How would I take an order, if all of a sudden we lost power or something? Um, it's inspecting, monitoring, and auditing, and checklists. I know Atlas is on. They do it very well. Ulrich Steel, everybody does. And then Jidoka is stopping a production immediately, using andon, not letting a process run very long, and again, that's where the control chart comes in. I don't, if I start to see outliers, I don't want to have another one. I got to stop and ask the question. So I better have a pretty robust process for Kaizen, whether you call it A3, you could call it Kaizen events, whatever, but I want to stop production immediately and it doesn't begin again until it's resolved. And with that, people, ta-da! Done. 1,400 slides, I think. Oh my God. Any questions, guys, about the next couple of weeks? The exam. Yeah, if you're not 100% on your homework, I know just a couple people just owe me a little bit. Good to get, just get them to me if you can. Anything?
So, Bill, one more time on just reviewing the schedule, because I know, like you said, next week, and then is the exam, you're going to hand out the exam?
Yeah, so next week, Laura, we're going to do a review of the whole course. And
Okay.
so hint, hint, because you've heard me say a lot, this is not an exam, this is not an exam. I kind of want to point you in the right direction, toward, tools that you're actually going to use probably
Mm-hmm.
moving forward. So next week's the review, and then, so as soon as the review's over, I'm going to email you guys a link to take the exam. And again, I suggest that you do it with your 4-person team. Just do one and then everybody, if that's the way you choose to do it. But you do have a week to do it because it'll be due a week from next Monday. But we'll not have a class that following Monday because I'm going to give you 2 weeks to prepare the final presentation. And then when that's done, there's a mug and a certificate suitable for framing for you all.
Okay. Yeah, I'm a little concerned just because I'm going to be out of the office from the 29th to the 5th.
Yeah,
So I don't want to slow down my team.
yeah.
Okay, I guess we could probably talk offline.
Yeah, I think there's probably others, always in the same boat. They got travel or whatever,
Okay.
Yeah. Who's your captain? Reach out to your
I think it was Marissa.
okay. Yeah.
Yeah, Marissa.
Yeah. You hear that, Marissa?
Yes, sir.
Yeah. All right. Any other questions?
Yeah, Bill, just side note, I jumped on late. Are you going to email out the teams after this meeting?
Yes, you'll have the recording. So I started out with the teams all color coded. I'm gonna also send you the slides for, and I think I have a whole with all of them together, the Mag, all the slides. Another not the PowerPoint, but a PDF of them all.
That would be great.
You'll get that in your hands, in case you want to flip through it for the test. What else? Nice job, people. This was a good one. Can't wait to see the presentations. I'll send you a couple more examples of final presentations too, so the group leaders can help their team pick a data set to make talk.
Okay.
All right.
Yeah, thanks, Bill.
Have a great night, people.
You too.
Thanks, Bill.
Bye. You're
Thank
welcome.
you.
Bye, Bill.
Thanks, Bill.
Thanks, Bill.